Well, pleasant day to each and everyone. Welcome to 42991 Advanced Water and Wastewater Treatment class. My name is Leonard Tihing. I'm a senior lecturer from the School of Civil and Environmental Engineering, and I'm one of the lecturers for this class. So basically, we have three modules, as mentioned by Professor Sean. We will have the first one, which I will handle on stakeholder engagement, including the water quality and water sources as well. The second one would be on advanced wastewater treatment using membrane bioreactors. And the third one would be on advanced treatment systems, water treatment systems, using reverse osmosis for desalination. So with regards to module one, which I'll be handling starting this time, we will have an assessment as well. And the assessment task one is on a report, an individual report about stakeholder engagement. So I will be explaining the details in this video that I make at the end of this video. And also it is the related guidelines and the details are also provided separately on Canvas. So please try to visit Canvas regularly as well and check out the materials and different reading materials and supporting materials from that site. All right, so if you have any questions with regards to the lecture on Block 1, please do not hesitate to contact me. If you have some questions with regard to the assessment, also please just contact me anytime through email, or we can arrange a meeting on Zoom to clarify things. For the meantime, I'm going to just record the some lecture videos about our classes during Block 1. So I'm looking forward to be spending time with you, even though just online, and I hope that you will still enjoy these type of classes and you will learn something from us. So so from here we will begin our lectures. So for our Block 1 Module 1 class, we will be discussing about the need for water discussions. This is in relation to the problem of water scarcity and how are we going to address it. The overview of the different alternative sources of water coming from desalination and wastewater treatment as well. And then we will be focusing more on community engagement in the water sector. So we'll discuss about the importance of community engagement or stakeholder engagement and know exactly what are the factors affecting how community accept the technology or the approach of preparing potable water, for example, or non-potable reuse. Then we'll discuss some of the case studies about stakeholder engagement, the success stories, and the not so successful stories as well. And then at the end of the Block 1, we'll be going to talk about an introduction to water quality, its importance, and the different parameters for water quality characteristics, the different water sources, and we'll be discussing about how to identify some of the various resources or various sources of water depending on their water quality. As we all know, water is one of the most precious resources we have on Earth. But at the present time, water scarcity is also one of the most pressing issues we are facing right now. By the estimate of the United Nations, in the year 2025, around almost 2 billion people, or approximately 1/4 of the global population, will be experiencing absolute water scarcity or physical water scarcity. So when we say about physical water scarcity, this means that the resource is not available, the water resource is not available in a specific area, or that they have the resource but the demand is much higher than the availability of that resource. And at the present time as well, around 1.6 billion people are already facing economic water shortage. And this, the difference between economic and physical, is that economic water scarcity referred to the availability of the resource, the water resource, but they don't have the infrastructure to harness that resource, or they don't have the ability to harness the resource, or they don't have the capacity, or they cannot afford to buy that resource. So these are two of the main issues right now in terms of physical and water scarcity. Most especially the issue of growing population. the exponential growth of our population has definitely helped in increased water use as well. So this means that our population increase, with the population increase, people use more water, and the effect of urbanization as well, and some pollution effect where water quality is degraded. And another one is climate change, where water evaporation is much higher, so there's more dry lands now. And so all of these factors have resulted to more water stress these days. So this is an example for example, in South Africa, where they need to collect water from some other place because they don't have that water resource in their place. So this is the usual way they do that. In our case, in Sydney, for example, or in Australia, we have water from the tap. Anytime we just open the tap and water comes out, but not for other nations, especially those that have physical water scarcity or even economic water scarcity. So an example is given here in this map. As you can see, with Australia is quite red, extremely high stress. We are one of the, in fact, we have the driest inhabited place on Earth. In terms of we don't have that much water, our precipitation is quite low, and then some other parts of the Earth as well are experiencing a lot of stress, water stress. So this means this is a global problem. So it's one of the major problems we are facing right now. Because of this, we can see from this slide here that in United Nations Sustainable Development Goals, which was developed in 2015 by the member nations, clean and water and sanitation is one of the goals, because they realize the importance or the need to address the water scarcity problem. So clean water and sanitation is Sustainable Development Goal number 6. And as you can see, there are 17 of them here, and they are interconnected with each other. So when we say water, then it also connected to energy, to climate action or climate change, and some other areas here as well, and life on land, life below water. So the clean water, the water scarcity that we are talking now affects more than 40% of the global population. That's why it's part of the goals here to sustain the supply of clean water and including sanitation as well. So it is more expected in a more negative expectation is it is projected that at least 1 in 4 people will be affected by water shortages in 2050. And then 80% of, or more than 80% of wastewater at the current time resulting from the anthropogenic activities or human activities are actually discharged into rivers or sea without any pollution removal. And this is very rampant, especially to underdeveloped and developing countries. So from manufacturing industries, the wastewater that are coming from there are just directly being dumped into the rivers and seas. And this definitely will affect the water quality of the receiving water. So if you're dumping into the river will be receiving a lot of biological matters, and increasing the BOD of a system will result in a very polluted case, and this will degrade much of the water quality. So that's why the receiving water will not be available anymore for further useful use. So this is the main problem at this point. And in fact, the wastewater is supposedly one of the alternative sources of having or treating it into something useful water or for reuse. So we will be discussing this type of approach in our next few slides here, or in this class as well. So overall, the clean water and sanitation goal is actually wanted to be achieved by the end of 2030. So the goal is to have everyone will have a safe drinking water at this point in time, and hopefully, because this is a very enormous challenge, so everybody's help is much needed for it to be achieved. So in relation to the United Nations Sustainable Development Goals, we also have the the National Academies of Sciences, Engineering, and Medicine, based from the United States, has come up with also with their own 5 grand challenges. And these grand challenges are more focused on the role of environmental engineers. And of course, this is not only limited to the environmental engineers. It could be any engineering field as well that can address these grand challenges. So there are 5 of them that they have listed in their grand challenges. It came out in their report last year in 2019. The first one is on sustainably supply food, water, and energy. So as you can see from here, these food, water, and energy are quite interlinked with each other. And if you look at this example, we can add climate here as another nexus. So we can be water, energy, food plus climate nexus, because each of them are actually affecting each other. Like for example, water is actually needed to produce energy, in the sense that you can produce energy by the use of hydropower, for example, which uses water, or you use water as a cooling water to cool down the water from heat exchangers or in cooling towers to produce energy in power plants. Also, energy is needed to produce water, because we need some technology like reverse osmosis. You input a lot of electrical energy for pumping in order to produce potable water. That is just one form of doing that. Fertilizers have their own chemical energy, which are used for agriculture, and for which it will grow plants and food. So this is also connected with each other, the food and energy. And of course, we know how much water we use for agriculture. In fact, agriculture is the biggest consumer of water. Around 7% is being consumed for agriculture. Now, all of these are quite related to climate, of course. The changes in our temperature, the global temperature, impacts the resources we have, especially on water, the resources we have on energy, and because energy is impacting directly the climate change because of the emissions, the CO2 emissions coming from the production of energy. The food as well is affected by the climate change, the changes in temperature, the drought, for example, or too much rain will affect how much food will be produced. So all of these are quite interconnected with each other, and the grand challenge is how to sustainably, to be sustainable, to have an indefinite supply of food, water, and energy in the future. And the second one is on curb the climate change and adapt to its impacts. Of course, this is quite related to what I have mentioned already. Design a future without pollution and waste. And this is an important aspect as well, because right now we have a lot of problems with pollution, not only in water pollution, but air pollution. So air pollution, the recent bushfire in Australia has also resulted to a lot of pollution problems. Waste is another issue here. So we have to design a future without, or at least minimize the amount of waste and pollution. And one of the biggest issues right now is in the form of plastics, or microplastics even, or nanoplastics, which are quite problematic in wastewater treatment plants, or even in the natural environment, like in seawater or in land. Even our houses has a lot of these microplastics waste. The fourth one is create efficient, healthy, and resilient cities. So this is about talking about more of having a smart city design. Smart city where maybe sensors will be put around the city in order to make sure that we maintain a healthy city by knowing the temperature, by knowing the humidity, or some automated parts of the, for example, during flooding, for example, there are some automated technology that will address flooding, or even the water flow in pipes, how much is being flowed there. There is what we call as AI technology there, for example. So this is also another challenges that needed to be addressed. And the last one that they have mentioned in the report is foster informed decisions and actions. And this is where also we are going to discuss more in our class, because this is related to informing not only those decision makers, but also the stakeholders. All right. So this is about connecting with the stakeholders in order to achieve the best result for a specific approach or a project. And we're going to discuss this more. So basically, out of the 5 grand challenges, our focus of this class would be on the sustainably supply of water. And another one is foster informed decisions and actions by good stakeholder engagement. So as part of the Sustainable Development Goals and also the grand challenges in the previous slide, the climate change is also one of the main focal points of need to be addressed in the future, because there's a really severe climate change problem right now. If you look at the global mean temperature, this is the temperature here, and this is the time frame. So we're seeing an increase of like 1 degree Celsius of global temperature since this point in time here. This is primarily because of the more uptake of fossil fuels during the Industrial Revolution when the steam engine was discovered. And then because of that, the increase in emissions of CO2 has been drastically or exponentially increasing since that time. So we can see and also an increase of the greenhouse gas emissions, which trap heat in the earth. So because of these enhanced greenhouse gas emissions, we're seeing climate change right now, or global warming. And this is very, very bad for our environment, because the higher the temperature change or the temperature increase will have much worse effect on Earth. Like for example, at this point, we are already experiencing glacial reduction, like we're destroying the habitat of some animals, and also because of this melting of the ice and glaciers, then the liquid becomes will add to the volume of your ocean, of our ocean, and thereby increasing the ocean level as well. And the increase in ocean levels or sea level will result into flooding of coastal areas, for example, and this will be a very very bad situation. In another side as well, because of the increase in temperature, global temperature, we're experiencing a lot of drought, a lot of dry lands, a lot of places without water, because at higher temperature they are increasing the evaporation of water as well, and then you are drying most of the surfaces. And so this is an example of people without access to potable water, or without access to any water at all. And so this is what we call as a new war in the future, is between the war of water supply. And another issue of climate change is on the movement of habitats. The animals are moving out in their natural home, and so they are also changing the way they live in their own habitat. And a lot of typhoons and a lot of bad weather are coming in because of the changes in the global temperature. So the issue of here is actually it's an energy problem because of the emissions, but the climate change has affected so much in the way we access or the resources we have in terms of water supply. So this is something that we also need to consider when we think about water scarcity. Is also a climate problem, related to climate problem. So let's consider our current situation in water situation in Australia as well. So in fact, Australia is considered as the driest inhabited continent in the world. So when we say driest inhabited continent, it means the driest continent with people or inhabitants. But even though we are one of the driest, or even we are the driest, Australians are one of the highest water consumers in the world as well. So we are quite affluent people. We try to use our water as much as we can. We are lucky enough that we can have water by just the turn of our taps, and we have also high quality water and we can drink directly from the tap. But we also use so much water in our everyday life, so we have also one of the highest water consumers. In terms of precipitation or average rainfall, we are also receiving declining rainfall in Australia because of some factors, especially on climate change. So from 1,200 millimeters of precipitation, it came down to an average of around 700 millimeters now. And in fact, in 2019, we have one of the lowest precipitations we had is 277 millimeters. And as you could have experienced before, it was so dry last year that we had experienced a lot of bushfire problems. So that's why, because we had no rain in the whole year last year. Another factor for this consumption that we have in Australia is the increasing population that we have. Right now, we are around 25 million people, and it's still increasing. And for this, out of our water consumption, the distribution would be 70% of what we are consuming actually goes to agriculture. And 14% of the water is actually for freshwater use. These are for domestic activities like in our houses. And 16% of that is for energy and industry, for manufacturing processes. Australia is one of the nations that we experience drought in more like a cycle. It happens every few years, and the last one would be the drought in Millennium Drought in the year 2000. That's why during that time we didn't have much rain, and so the government decided to build desalination plant to augment the supply of potable water. But then suddenly the rain came, and so the desalination plant was on standby until last year. Last year we also experienced quite a dry year, and so our dam levels went below the safe level, and it went below 60% of the capacity of the dam. And usually, if it goes below 60%, then usually the desalination plant is activated. So during that time, the dam level went really below 50%, and so the desalination plant was reactivated, and now it's producing water as an augmentation to our drinking water. There are during this drought, or during this time that we have some water shortage, with the government or the Sydney Water is actually giving some water restrictions, and it is different levels. So this is level 1, 2, and 3, based on depending on the availability of the water in the dams. So last year we were on level 2 of the water restriction because of really low dam capacity now, but dam level I mean. But then right now at the present we are back to level 1 because a lot of rain came in the first few months of this year. So a lot of rain came, and so our dam levels went back to around 80%. But still there is a level 1 restriction because we are not really sure. It's like a temporary relief. For example, if the rains were temporary relief, we don't know how long it will last to maintain that level in the dam. So there are still restriction level at this point. But these levels are a way to secure the way we control our outdoor use of drinking water. So we're trying to control it. So the different levels of restriction means different how excessive the restriction would be. Like for example, with the use of water to water your garden, or to fill up your swimming pool, or even to wash your car. So it depends on the different levels of restriction. So this goes to show that because of the cycle of the water shortage in Australia in some few years, then we need a source of a water resource that could supply that can provide security in the future, for example. And one of the approaches was on desalination, which we are going to deal with our lectures or our class. And also another way is to use wastewater as an alternative source of non-potable reuse water, or probably even for potable use water. So we will be discussing those technologies in our class. So as a way of sustainable water management, we need to include some non-conventional approaches, as I mentioned. Conventional sources would be, right now we are using dams as storage for water and or reservoir, and then some lakes and rivers as a natural reservoir as well. But there are some non-conventional or unconventional approaches, and these are water reclamation or wastewater reuse and seawater desalination. So the sources will be from wastewater, and we are turning wastewater into something useful. So we're reusing the wastewater and make it into useful water. And so the quality of the wastewater will be improved based on new technologies. And the other one is seawater desalination, because as we all know, seawater has a very big, we have a very big amount of seawater in the world. So why not use this resource in order to provide some potable or non-potable use? So let's start with wastewater reuse. So water reuse or wastewater reuse is the use of treated wastewater for beneficial uses. So it means that the key here is beneficial. So it really depends on your end use. So the quality of the produced water from the treatment plant, for example, this is a wastewater treatment plant. It depends on what kind of end use you are going to do. For example, for washing or flushing or irrigation, cooling. So the quality will also depend on that one. We don't really need an A-grade quality if we are only using for this kind of purposes, because they are what we call as out-of-body use. But if we are referring to drinking water, for example, of course, we have different standards for each one, and drinking water is the highest standard that we need to have as a water quality. So this is an A grade for this. The rest should be lower than the quality of drinking water, but should pass the standards on specific uses of this water. And so one of the technologies that used for, especially for potable wastewater reuse technology, is a multi-barrier treatment system. So the multi-barrier treatment system ensures that all the possible pollutants or contaminants inside the wastewater are treated, or actually not allowed to pass or to be present in the produced water or the potable water. So for example, if we have a sewage water here, it has different barriers. So it is barrier number 1, 2, 3, 4, and 5. So this is a multi-barrier system. So in this case, from big things and some other things that don't pass through the membrane, they are segregated here, separated by the use of a membrane. And then whatever that passed through the membrane will again be destroyed by a UV disinfection part here. And then it goes towards a reverse osmosis process, which uses a much is a dense membrane that only allows water molecules to pass through. Of course, there are some that are quite small things that can pass through as well, but then there's another barrier system that would enable to further reduce whatever contaminants you have in that water at this stage. And then lastly, it will go towards, if there are bacteria still here, then it will go towards a more disinfection process before it goes to being a potable water. So there are still some mixing of minerals here, some changing the pH and all, but this part here should be at a quality that is acceptable in the standard, like the World Health Organization standard or the Australian Drinking Water Standard. Okay, So this is a way of using mainly membrane systems for this. So in our class, we will be using a process called membrane bioreactor to treat the wastewater, and reverse osmosis is used for desalination. And this will be further discussed in your Module 2 or Block 2 class, and also in Block 3 class. So the other unconventional approach is through desalination, and mainly if we all know what desalination is. It's just basically a process of converting the seawater into potable water by separating the salts that are inside the seawater. And the separation process is using the process of reverse osmosis as being the state of the art. That is the most common process right now, or via thermal desalination also. It's possible to just heat the water and then condense it back into pure water. But this has a lot of energy that is consumed, although this is also very energy intensive process, but it's very efficient. It uses a membrane, a reverse osmosis membrane that that stand as a barrier between the salt water and the fresh water with the addition of applied pressure. This pressure is needed because there are a lot of different components inside the seawater. So if you look at the seawater here, most of the components or constituents are chloride and sodium. That's why it's NaCl is most of the component of the salts. And there are other minerals and some metals as well that are composing that seawater. So we need some pressure to enable to only allow the water to pass through and not the salt, right? So as a lot of water in the seawater, only 35 grams is there for 965 grams of water. So there's a lot of opportunity to get this fresh water out of seawater. And besides, we know that 90 almost 98% of the water in the world is ocean or seawater. So there's a vast resource for this one, right? The only maybe problem is the energy consumed or the energy consumption of the process. But then again, this is one of the better ways to make sure that you have water security in terms of water supply as well. More of this will be discussed in the next slides or the next lectures. Though there is a great opportunity for the use of wastewater or seawater as an unconventional source of new potable water, or even for non-potable water use. The acceptance of the use of these new sources of water is still not fully accepted, especially in terms of reusing wastewater into drinking water, for example. And even not for drinking water, even for the thought of reusing the water into something that has a near body experience. So drinking water would be the ultimate use for that one. So the perception is an important aspect that we need to consider if we are to proceed on a project that involves wastewater, right? So most especially if the project is about for portable purposes or for drinking purposes, because there's a lot of psychology involved in this matter. The public perception is an important factor in the success of a specific project, even especially related to water. So let's take, for example, in these photos here, in these figures here, what do you think comes to mind? What comes to mind when you look at these figures? So even though these figures are just basically food, and they are food, yes, but they are presented in such a way that that will give you some imagination, and this imagination is more of psychological thing. And so having to look at this one and also try to relate into something, then most probably you will have a yuck factor or a yuck feeling. because you are relating these photos into something that is not so mentally appetizing. All right, so this is what we call as the yuck factor. It's the same way when we talk about wastewater, that from wastewater and then change or transforming it into potable water. So the process in between is another issue, but even with just the thinking of you are drinking a water that used to be from your toilet, for example, is not so appealing to the masses or to the community. So this is one of the barriers for the acceptance of this kind of process, especially from wastewater. Because desalination is a better case, because at least in desalination, the source water is from seawater. So seawater in itself is not very dirty to the mind, or not very dirty at all, in fact. But for wastewater, it's a different case, because wastewater, of course, is a mixture of so many yuck things, or so many not so appealing things. And so this is something that we need to discuss as well, about the community acceptance on the reuse of water, or wastewater reuse. So with that, we'll be discussing what approaches we can do in order to increase the chances of the public to understand and accept the potential use of treatment process in order to produce a quality that is at par or even beyond the standards, the standards that are required for that water quality coming from a wastewater treatment process. All right, so this will be discussed in our stakeholder engagement part. And to do some of the projects related especially to wastewater, we will do some analysis in terms of the SWOT analysis, which is the SWOT analysis, the strength, weaknesses, opportunities, and threats. So we need to identify what are the different areas that need to be focused on. Like, for example, what are the weaknesses of the project, of that wastewater treatment project, for example, what sort of opportunities can be done so that it can increase the chances of being accepted or being successful. And with these different areas of identification, we can also know some aspects on how to engage the community, which one to focus on and how to address it. And besides that, we can also do an engagement matrix. So an engagement matrix is basically trying to put into a matrix which the different kinds of types of stakeholders that you are going to deal with. So these are different kinds. Those stakeholders that are not too important, for example, is just spectators. So they don't need to be, they don't need your much effort focus on them. You need to focus your effort on people who have influence to the specific project, for example, who are the key players, focus on this group, whose needs need to be met, for example. So you have a matrix of the interest of the stakeholders and the influence or power of the stakeholders. So this kind of strategy we are going to discuss in our next slides, in the next lecture. So for Block 1 or Module 1 classes, there's a related assessment for this one. And as just to recap, each module or each block class will have its own assessment. So for this time, your assessment is the stakeholder engagement, and this is an individual report, and this is worth 30%. And the deadline for this one is on 26 April until midnight. And please submit on Word file only, not PDF, because this is just to avoid any plagiarism. With PDF, at least we will know if there are some JPEG files inside the file. And please try to follow this file name so that it's easy for us to store and arrange your report. So basically, we have a scenario document provided, a separate one that for all your assessment will be based from that scenario document. However, I have provided, it's a related one, but I have provided this format that you need to follow for your assessment task 1 report, for this report. Okay, so basically it's about stakeholder engagement or community engagement. So the major part is somewhere from 3 until 5 here. You can say, okay, you can see some situational analysis like the SWOT analysis, stakeholder analysis, and the engagement process or evaluation strategy. So you can start off with the basic cover page, table of contents, and then of course you have to provide an abstract or a summary and on a limited words. Do not make it too long, and there's corresponding marks for each section as well. Okay, please be guided accordingly. So basically the scenario for this one is pretty much related to the scenario given in a separate document, but the scenario in this one is more focused on having a direct potable reuse project in Sydney. Okay, so the scenario is that what if there is a project for a direct potable reuse and it is proposed to be built in Sydney. So the keyword is direct potable. So this is for drinking purposes. As of this point in Australia, we don't have a direct potable reuse treatment plant. All right, so these are all indirect. And so what if we are going to suggest a direct potable reuse plant? So this is basically the situation in that one, and you need to put your stakeholder analysis based on this situation here for a direct potable reuse plant. So please provide a good background about the water situation in Australia. In Australia is basically based on the Sydney Metropolitan Water Plan that is given to you in document as well. Discuss the different initiatives there. What is the role of wastewater reuse in that initiative? Of course, in that initiative, there is also desalination there. But please focus your report on wastewater reuse here. And then I want you to do a literature review on the status of direct potable reuse around the world. So please try to search which places are using or have used direct potable reuse technology or process. Okay, so you can input that one there. Identify what they are doing and which technology they are using as well. Okay, so you have to identify these things. This is worth 15 marks. And then after that, you need to do a SWOT analysis of that situation in Sydney. All right, so we need to see a SWOT analysis based on a direct potable reuse in Sydney, a reuse plant in Sydney. Try to see the strengths, the weaknesses, opportunities, and threats for building a direct potable reuse. All right, so for example, one of the strengths maybe of having it in Sydney is that there is a good support from academe and researchers in terms of the efficiency of a technology, a viable technology to treat the wastewater in order to make for potable reuse. Okay, that's one of possible strengths. The other one is the section 4 is on stakeholder analysis. So you need to identify who are the key stakeholders for the building of a potable reuse plant, for example, and then what are their roles and which in the stakeholder matrix, what levels of interest and influence do they have. So I mentioned in the previous slide, there is a matrix of like a graph here where you put in different section where is the most focus we will give, who are the stakeholders that we need to focus on. So the highest influence and the highest interest. All right, and then identify the most important stakeholders, as I mentioned. And then the fifth one here is on engagement. What approaches are you going to suggest in order to engage these stakeholders that you have identified? Okay, so how do you approach them? How do you engage them? How do you get their trust? Or how do you make sure that they support your project? Okay, so these are the things that is quite major of this report as well. And then of course you need to give a reflection of what you have learned through this process. What is the conclusion as well? For example, who are the major stakeholders that need to focus on, and what sort of process or approach you are to how to engage them. All right, you need to put in your conclusion, that is 10 marks. And then references, you need to put your references throughout the report. You need to make sure that you are citing their citations. You are citing the sources of your arguments or your figures or your table. All right, it's important that you make good citations, and a minimum of 25 references is expected. Make sure that your references are new references within the last 5 years of publication would be good references. And please refrain from referencing Wikipedia or some other not known websites. So government websites, for example, should be okay, but mainly try to refer to journal articles, some reports or books. These are the peer-reviewed documents. So it's important that you reference from these sources. Also, make sure that your references you will use reference manager like EndNote. So EndNote, I hope you know how to use it. It's important to use a reference manager. EndNote is one, but you can also use other software or reference manager as long as you have a reference manager. And of course, the other parts of the assessment would be the overall format of your report, the structure, how you write it, how clear is your writing, the language, as well as about 10 marks as additional marks for this one. So overall, these 100 marks. All right. So if you have questions with regards to assessment, don't hesitate to email me, and then we can also talk on Zoom if you want to discuss these things. But I'm hoping that based from what I have provided here, it will serve as a guide for you. You can just answer each one of these guide, or you can add more if you wish, as long as you will have the quality that is expected of this report. All right, so please, there's another separate guideline which is more details there. Please try to read that guideline so you will be guided accordingly. Okay, so for our next videos, we will talk about community engagement, the various factors of community acceptance, especially in the use of for reused water. And also we will discuss about water quality and its importance, and also what kind of the various water sources as well.